current weather conditions are sunny and warm, with temperatures in the mid-70s degrees Fahrenheit. A light breeze is present and the sky is clear. This contrasts sharply with snowy conditions experienced elsewhere. When performing electrical work, several factors should be considered to ensure safety and compliance with regulations. Firstly, always disconnect the power supply before starting any electrical work. This can be done by turning off the appropriate circuit breaker or removing the fuse. Secondly, use appropriate tools for the job. Insulated tools are essential to protect from electric shock. Wire strippers, pliers, screwdrivers, and voltage testers are common tools needed for electrical work. Thirdly, follow the National Electrical Code or NEC guidelines. The NEC provides standards for safe electrical installations. Compliance with the NEC is crucial to prevent electrical hazards and ensure the safety of the installation. Fourthly, ensure proper grounding. Grounding provides a path for fault current to flow back to the source, tripping the circuit breaker and preventing electrical shock. Grounding is typically achieved by connecting metal enclosures and equipment to a grounding electrode system. Fifthly, use the correct wire size. Wire size is determined by the ampacity or current carrying capacity of the wire. The ampacity must be sufficient to handle the expected load. Using undersized wire can cause overheating and potentially lead to a fire. NEC Table 310.15b16 provides ampacity ratings for various wire sizes and insulation types. Sixthly, make secure connections. Loose or corroded connections can cause arcing, overheating, and electrical failures. Use appropriate connectors and ensure they are properly tightened. Applying antioxidant compound to connections can help prevent corrosion. Seventhly, label circuits clearly. Clearly label each circuit breaker or fuse to identify the corresponding loads. This helps with troubleshooting and maintenance. Eighthly, test the installation. After completing the electrical work, test the installation to ensure it is functioning properly. Use a voltage tester to verify that circuits are energized correctly and that there are no shorts or ground faults. Ninthly, consider the environment. Wet or damp environments require special precautions, such as using ground fault circuit interrupters or GFCIs to protect against electric shock. Outdoor installations must be protected from the weather. Tenthly, obtain necessary permits and inspections. Depending on the location and scope of the electrical work, permits and inspections may be required. Contact the local building department to determine the requirements. Let's delve deeper into some specific electrical concepts. Understanding voltage, current, and resistance is fundamental. Voltage is the electrical potential difference between 2 points, measured in volts. Current is the flow of electrical charge measured in amps. Resistance is the opposition to the flow of current measured in ohms. Ohm's law describes the relationship between voltage, current, and resistance. Voltage equals current times resistance, or volts equals amps times ohms. Understanding circuit types is also essential. Series circuits have components connected in a single path, so the same current flows through each component. Parallel circuits have components connected in multiple paths, so the voltage is the same across each component. Combination circuits have both series and parallel components. Another important concept is power. Electrical power is the rate at which electrical energy is transferred, measured in watts. Power equals voltage times current, or watts equals volts times amps. Understanding power factor is crucial for efficient energy use. Power factor is the ratio of real power to apparent power. A power factor of 1 indicates that all the power is being used effectively. A power factor less than 1 indicates that some of the power is being wasted. Improving power factor can reduce energy costs. Regarding wiring methods, several options are available. Non-metallic sheath cable or NM cable, commonly known as Womex, is used for residential wiring. It consists of 2 or more insulated conductors enclosed in a non-metallic sheath. Metallic conduit, such as rigid metal conduit or RMC, intermediate metal conduit or INC, and electrical metallic tubing or EMT, provides protection for conductors in harsh environments. Flexible metal conduit or FMC is used for connecting equipment that requires movement or vibration. Understanding grounding and bonding is essential for safety. Grounding provides a path for fault current to flow back to the source, tripping the circuit breaker and preventing electrical shock. Bonding connects metal parts to create a low impedance path for fault current. The grounding electrode system typically consists of a ground rod, ground plate, or underground metal water pipe. Ground fault circuit interrupters or GFCIs are life-saving devices that protect against electric shock. GFCIs monitor the current flowing in the hot and neutral conductors. If there is a difference of 5 mA or more, the GFCI trips, interrupting the circuit and preventing electrical shock. GFCIs are required in wet locations such as bathrooms, kitchens, and outdoor areas. Arc fault circuit interrupters or SIs protect against fires caused by arcing faults. SIs detect abnormal arcing conditions and trip the circuit breaker, preventing a fire. SIs are required in many areas of the home, such as bedrooms and living rooms. Surge protection devices or SPD protect electronic equipment from voltage surges. SPD divert excess voltage to ground, preventing damage to sensitive electronics. SPD are recommended for protecting computers, televisions, and other valuable electronic devices. When working with electrical panels, always exercise extreme caution. The electrical panels contain live circuits and can be dangerous. Never touch any exposed wires or components inside the panel. Use insulated tools and wear appropriate personal protective equipment or PPE. Before working on an electrical panel, turn off the main circuit breaker to disconnect the power supply. When replacing circuit breakers, use the correct type and size. Circuit breakers are designed to protect circuits from overloads and short circuits. Using the wrong type or size of circuit breaker can compromise the safety of the installation. When wiring receptacles, ensure proper polarity. The hot wire is connected to the smaller slot, the neutral wire is connected to the larger slot, and the ground wire is connected to the grounding terminal. Incorrect polarity can cause electrical shock. When wiring switches, use the correct wiring configuration. Single pole switches control a light or a receptacle from one location. Three-way switches control a light or receptacle from two locations. Four-way switches control a light or receptacle from 3 or more locations. When installing lighting fixtures, follow the manufacturer's instructions. Ensure that the fixture is properly grounded and that the wiring connections are secure. Use the correct type and size of wire for the fixture. When working with low-voltage lighting, such as landscape lighting or under-cabinet lighting, use a low-voltage transformer to reduce the voltage from 120 volts to 12 volts or 24 volts. Low-voltage lighting is safer to work with and consumes less energy. When installing data and communication wiring, such as Ethernet cables or telephone wires, follow industry standards. Use the correct type of cable and connectors. Ensure that the wiring is properly terminated and tested. When working with motor circuits, understand the motor's nameplate information. The nameplate provides information about the motor's voltage, current, horsepower, and other important parameters. Use the correct type and size of motor starter and overload protection. When working with control circuits, understand the control system's logic. Control circuits are used to control various equipment and processes. Use the correct type of control relays, timers, and sensors. When troubleshooting electrical problems, use a systematic approach. Start by checking the circuit breaker or fuse. Then use a voltage tester to check for voltage at various points in the circuit. Use a multimeter to measure resistance and current. When repairing electrical equipment, use the correct replacement parts. Ensure that the replacement parts are compatible with the equipment. Follow the manufacturer's instructions for installation and repair. When performing electrical inspections, use a checklist to ensure that all aspects of the installation are inspected. Check for proper grounding, bonding, wiring methods, and overcurrent protection. Document any deficiencies and recommend corrective actions. When designing electrical systems, consider the load requirements, voltage drop, and overcurrent protection. Use the NEC guidelines to ensure that the system is safe and compliant. Prepare detailed electrical drawings and specifications. When installing solar photovoltaic systems, follow the NEC guidelines for solar installations. Ensure that the system is properly grounded and protected from overcurrent and surge events. Use the correct type of wiring and connectors. When installing wind power systems, follow industry standards for wind turbine installations. Ensure that the system is properly grounded and protected from lightning strikes. Use the correct type of wiring and connectors. When installing energy storage systems, such as batteries, follow industry standards for energy storage installations. Ensure that the system is properly ventilated and protected from overcharging and discharging. Use the correct type of wiring and connectors. When working with hazardous locations, such as areas containing flammable gases or dusts, follow the NEC guidelines for hazardous locations. Use explosion-proof equipment and wiring methods. Ensure that the area is properly classified and that the equipment is suitable for the classification. When working with high-voltage equipment, such as switchgear and transformers, exercise extreme caution. High-voltage equipment can be extremely dangerous. Only qualified personnel should work on high-voltage equipment. Use appropriate personal protective equipment and follow safety procedures. When performing maintenance on electrical equipment, follow a preventative maintenance schedule. Regularly inspect and test electrical equipment to identify potential problems. Clean and lubricate equipment as needed. Repair or replace damaged parts promptly. When disposing of electrical equipment, follow environmental regulations. Many electrical components contain hazardous materials, such as lead and mercury. Dispose of these materials properly to prevent pollution. When working with electricity, always remember to prioritize safety. Electricity can be dangerous if not handled properly. Follow safety precautions and use common sense. If unsure about any aspect of electrical work, consult with a qualified electrician.